This video is how to answer the complex numbers tutorial. So question 1, z1 is equal to minus 4 minus 5i, z2 is equal to 2 plus 4i. Find the following, z1 plus z2. So what we're going to do is we're going to add the real parts first. So that's minus 4 plus 2, so that's obviously minus 2. And then we've got minus 5i plus 4i, so that's minus i. Am I right? Yes, I am. Good. Okay, second one is z2 minus z1. So we've got 2 minus minus 4, so that's going to be 6. And then we've got 4i minus minus 5i, so that's going to be plus 9i. Are we right? Yes, we are. Okay, question 2. Given z1 is equal to that and z2 is equal to that, find z1 times z2. So first of all, let's just copy z1 and then copy z2. And then we want z1 times z2, z1 times z2 equals, and remember to use the star character. If you put an x in there, any software would interpret that as z1 times x times z2, and that's not what you want. So as before, we're going to do the real parts first. So we've got minus 7 times 6, that's going to be minus 42, and then we've got 4i times 2i, so that's going to be plus 8i squared. Okay, and then we've got minus 7 times 2i, so that's going to be minus 14i, and we've got 6 times 4i, so that's going to be plus 24i, isn't it? Okay, and that's going to equal 8i squared. I squared is equal to minus 1, so 8i squared is minus 8. So minus 42 minus 8 is minus 50. And then we've got minus 14i plus 24i, so that's obviously 10i, minus 10i. And are we right? Yes, it's not minus 10i at all, is it? It's plus 10i. Am I right? Yes, I am. Okay, so that's 24 minus 14 is 10, not minus 10. Okay, so for z1 and z2, let's just copy those down, Control C, and stick those in there. And remember that everything to the right of the equals greater than symbol is feedback that Babbage gives you, and Babbage deletes that automatically when you press when you say am I right, so we don't need to worry about that. Right, so now what we're going to do is z2 times z1. So I'm going to pull in a it's called a whiteboard, but actually it's black, so I can show you how to do this. So let's have a pen. There we go. So we've got z2 is equal to 6 plus 2i, 6 plus 2i, and z1 is equal to minus 7 plus 4i. Okay, so z2 divided by z1 is equal to 6 plus 2i divided by minus 7 plus 4i. Now I'm going to multiply both sides by the denominator's complex conjugate, so that's minus 7 minus 4i. That makes the denominator real. We don't want a complex denominator, and we're going to multiply the numerator by the same, so it's minus 7 minus 4i. Okay, so as before, we'll do the real parts first. So I'm going to get minus 42, and then I'm going to get minus 8i squared, so I'll just put that as plus 8, and then we're going to get 6 times minus 4i, so that's going to be minus 24i, and then I'm going to get 2i times minus 7, so that's minus 14i, and then for the denominator it's just going to be that squared plus that squared, so that's 49 plus 16. Okay, so we need another line here. Minus 42 plus 8 is going to be minus 34, and minus 24i minus 49, that's going to be minus 38i, 38i, and that's going to be divided by 49, 59, 65. Okay, so we'll stick that in to our answer. Let me just slide that across to there. So we want Z2 divided by Z1 is equal to brackets minus 42 plus 8 minus 24i minus 14i bracket divided by 49 plus 16. Okay, that's what we're doing, and that's going to equal, what do we say, minus 36 minus 38i divided by 65. Okay, and are we right? No, why did I say 36? It's 34. Are we right? Yes, good. Okay, right, we're now using the cos plus I sine form of the expressions. So we'll give Z1, we'll give Z2, and we want Z1 times Z2 equals, these are nice and easy, 6 times 7 is 42, brackets, let me just copy these, stick them there. So we now add the arguments here, so it's 28 plus 32, that's to say 0.28 plus the 0.32 is going to be 0.6, isn't it? So we delete those, and we want a 0.6 there. Okay, are we right? Yes, we are. Good. Okay, let me copy these and pop them in there. And this time we want Z1 divided by Z2, and that's going to equal, so instead of multiplying these together, this time we divide them, so it's going to be 6 divided by 7, brackets, have I still got that? Yes, no I don't. So I want this and put it in there, and now what we're doing is it's Z1 divided by Z2, so it's 0.28 minus 0.32, so that's going to be minus 0.04, and this will also be minus 0.04. 32 minus 28, yeah, that's right. So are we right? Yes, we are. Okay, question 4. Find the real roots of all of this. So let me just write those down on the whiteboard. So we've got, I'm going to start by writing the factor that we're given, 3x plus 2 plus 4i. So I need to drag that in here. Yeah, so we've got 3x plus 2 plus 4i, and we're going to multiply that by its complex conjugate, because we know that the roots of any equation, if it's complex, the complex conjugate must also be a root. So we know that another root is going to be 3x plus 2 minus 4i. Okay, so we're going to multiply that out, so we're going to get 9x squared minus plus 12x, that's the 3x times 2, and we've got 2 of those, and then we're going to get plus 4, which is the 2 times 2, and then we're going to get plus 16, which is the 4i times minus 4i, which will give us minus 16i squared. The I squared is equal to minus 1, so that becomes plus 16. Okay, so we'll stick that in just to be sure that we're right so far. So we've got Q1, which is the first quadratic. Q1 is equal to, what do we say, 9x squared plus 12x plus 20. And am I right so far? Yes, good. Okay, so now what it said, let me just delete that for a second. So it says find Q2 by dividing the quartic, that's to say the 54x to the fourth and everything, by Q1, the thing that we've just calculated. So we'll put that back in there, and then we'll do that division. So what I want to do is move the board up a bit. So I'm going to get 9x squared plus 12x plus 20, and I'm going to divide that into 54x to the 4 minus 54x cubed minus 12x squared minus 232x plus 80. Okay, and that line needs to be extended a little bit. So the first question is, what do I have to do to 9x squared to get 54x to the 4? And the answer is multiply by 6x squared. So 6x squared, I'm going to multiply all of this by 6x squared, so I'm going to get 6 9s are 54, 54x to the 4, and then 12 6s are 72, so that's going to be plus 72x cubed. 20 times 6 is going to be 120, so that's plus 120x squared. Okay, I'm going to subtract those, obviously they will disappear. Minus 54 minus 72 is going to be minus 126x cubed, and minus 12 minus 120 is going to be minus 132x squared. And now I'm going to bring this term down, so that's going to be minus 232x. Okay, so what do I need to do to 9x squared to get minus 126x cubed? Think about it. So that's minus 14x. I multiply it by that. Let me just check. 14, that's 19, that's 36. Yeah, that's right. So I'm going to multiply each one of these by minus 14x. So I'm going to get minus 126x cubed. 12 times 14 is minus 168x squared. And then 14 times 20 is going to be minus 280x. Okay, so we'll subtract those. Let's just move those up a bit. So the first terms cancel, and we've got minus 132x squared minus 168x squared, which is going to give me 36x squared. And then we've got minus 232x minus 280x, which is going to give me plus 48x. And then we bring the 80 down, plus 80. Okay, so now what do I have to do to 9x squared to get 36x squared? Well, obviously I multiply by 4, that's nice and easy. So I've got 36x squared plus 48, so that's 12 times 4, so that's 48x, and then 12 times 20 is plus 80. Okay, good. So that all cancels, which means that we've now got the divisor is the 6x squared minus 14x plus 4. So I'll put that back in here. So we've got Q2, which is the second quadratic. Oops, hang on. Q2 is equal to 6x squared minus 14x plus 4. Okay, and are we right? Certainly would want to check that. Yep, we are. So far so good. Okay, so now we've got to factorize that. So 6x squared, so that's like 3x squared minus 7x plus 2, which is going to give us x1. x1 is going to equal 2, and 3x x minus 1 is going to be a root, isn't it? So x2 is going to equal 0.33 recurring. Okay, you can check that, but I'm confident that's right. So are we right? Yes, we are. Good. Okay. So that's question 4. Question 4 is quite tricky, but as long as you take all the steps, then you'll be okay. But let me just delete all of that for a second and just show you how the this placeholder is telling you what to do. So the first thing it's saying, find Q1 by multiplying its factor by the complex conjugate. Okay, we do that. We then divide the quartic, which is this thing here, by the quadratic that we've generated. Okay, and that is Q2. And then when we've got Q2, we factorize that by whatever means that you're comfortable with, and those are called x1 and x2. Those are the real roots. Okay, so if I put that back in, so Q1 is that, and what we're telling Babbage here is that this is my answer to Q1. It sort of doesn't matter the order you put them in, but you have to say that what Q1 is equal to, you have to say what Q2 is equal to, and then with x1 and x2, it doesn't matter which order you get them in. Babbage will cope with that, but obviously you've got to say this is one root and this is the other root. Okay, so fifth roots of 7. Right, so let me just show you what they're going to look like. So let me have my whiteboard back. So it's the fifth roots of 7. So let me just drag that up. So this is 7 square root, listen to me, fifth root of 7. So this is what it's going to look like. So let's have some axes and let's change our pen color. So it's 7, so we can take the fifth root of 7, that's going to be a number out here somewhere. And then the other roots, there are going to be 5 of them, so each one is going to be 72 degrees beyond the last one. So we're going to get the other 5 roots are there. So that's one root, and those are the others. And that's meant to be a circle. It doesn't look much like a circle, but basically this is 72 degrees in here. 72 degrees. This is 72 degrees. That's 72. That's 72, and that's 72. 72 is 360 divided by 5, in case you hadn't twigged that. So we've got 5 roots, and 4 of them are complex, and that's what we need to find out. So what we're going to do is we're going to get 360, and we're going to divide that by 5, which is where we get the 72 from. And then this point here is going to be the square root of that. Let's call it r for now. So r is equal to the, I say square root, I mean the fifth root of 7. So the first term here is going to be, so that's root 1 is equal to that. So let's call it root 2 is equal to, it's going to be r times cos of 72 plus r sine 72. Okay, and that's going to be this point here. So I'll just cut to the chase then and say that our first root is, let's have a calculator. Where's my calculator gone? We want the fifth root of 7, so it's 7 x to y, and that's going to be 1 divided by 5. Let's put it that way. You can put 0.2 on if you wanted. Okay, so that's 1.48. So one of the roots is going to be 1.48. The next root is going to be, where's my calculator? There we go. So I'm going to save that. So Shift Store A, because I'm going to need that number, aren't I? Now I'm in degrees, that's okay then. So the real part of it is going to be 1.47 times the cosine of 72, and that's 0.46. So that's 0.46, and this is going to be positive, isn't it? So let's get my calculator back, and so now I want, let's clear that, and now I want recall a times, this time I want the sine of 72. Okay, and that is equal to 1.4, so it's going to be 1.4i, isn't it? So now we'll do the next root, which is going to be recall a times cos of 144 degrees this time, and that's going to equal minus 1.19 minus 1.19. So rather than calculate the next two roots, I'd just like to draw something to your attention. What we've got is the 5 roots are here, all on a circle, which means that the x value of this point is the same as the x value of this point, and the y values are the same magnitude but different signs. So the x value of this and the x value of this are the same, and the y values are the same magnitude but different signs, which means that rather than calculate everything, I can now just copy these and paste them in there and just change the y values. So that's going to be a minus, and that's going to be a minus as well. So am I right? Yes, I am. Okay, I'll do this one because this is dead easy, this one, the 4th root of 5. So let's just have a look at what that actually means. So let's move that up a bit. We're talking about, let's change my pen color again. So we're talking about the 4th root of 5. Okay, so let's have some axes. Let's have my red pen. So the 4th root of 5 is going to be a number, isn't it? So that's one of the roots. And the other one, and because there are 4 roots here, I know that they all have to be 90 degrees apart, which means one root has to be there, one root has to be there, and one root has to be there, because it's the 4th root, so 360 divided by 4 is going to be 90, which is why I know that's where they're going to be. We know that this distance here is whatever the 4th root of 5 is, and these are all going to be in those axes. So I'm going to get, this is real but negative, this is imaginary, and this is imaginary and negative. Okay, it's going to be that simple. So let's call up a calculator and ask for 5 to the point 0.25. You can do that, or you can do 1 divided by 4. I don't care. So that's going to be 1.5, isn't it, to 2dp? So the 4 roots here are going to be 1.5 minus 1.5, 1.5i, and minus 1.5i. Okay, and those are the 4 roots of 5 to 2dp. Am I right? Yes, I am. Okay, I did no calculation there. It was nice and easy. And that is how you solve all the questions on the complex number tutorial.